Hi there. Thanks for joining us again. This is Space Nuts. My name is Andrew Dunkley, your host. It's always good to have your company. Hope you're well. This is a Q&A episode, and in this particular show, we're going to be answering audience questions. One about planetary atmospheres, another about FAA approval for things like Reflect Orbital, which we talked about not so long ago. And funnily enough, at the very same time as someone asked that question, a story pops up in the news. So we'll have a quick look at that. Also, planets forming without a star. Is that possible? And if we've got time, we'll chuck another one into the mix. And we'll answer them all on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us once again while Fred is gallivanting in places that he ought to be, because that's what he does, is Professor Jonty Horner, Professor of Astrophysics at the University of Southern Queensland. Jonty, hello.
Good afternoon. How are you going?
I am well. Good to see you again.
Oh, it's good to be back. I'm enjoying the warmth of my fire here and thinking the warmth of the fire is a little bit too much warmth, actually, but it's a hard life.
I wish I had that problem. It is absolutely freezing in my studio here. We are not quite at the end of winter, although we're getting there, but that doesn't mean the cold will go away, because that's not how it works. The heat stays a bit longer than summer and the cold stays too much time past winter, in my opinion. I'm a summer person, but I think it's the campfire analogy that describes best how the seasons work. The heat.
All down to thermal inertia, and growing up in the UK, we're very familiar with that.
Yes.
The ocean is a blanket that keeps you warm, but it takes time to warm up and cool down.
Exactly.
So, yeah, hottest time of the year is always a few weeks after midsummer, and the coolest time of the year is usually a few weeks after midwinter.
Indeed. Which we're into, we're beyond that now. Should be starting to warm up. Should be. I know the hay fever's already hitting me. I mean, it seems to get earlier year in, year out. That's really frustrating. I've got my anti-hay fever device right in front of me now.
And it's been so dry recently as well that we've got all the wattles coming out, which for the listeners in the Northern Hemisphere, wattles are awesome and they're beautiful.
Yes.
But also we have all the dust because it's been the dry season. And so, I've got one of my students has had horrific problems with hay fever and visits to ENTs and stuff like that. So everybody's suffering. Get well soon.
It can be debilitating. Yes. Shall we deal with some questions?
Dive on in.
Let's go to our first one. Greetings from Perth. Been an avid listener for years. My dog loves the show too, as I listen while walking him. He has a question. No, he doesn't. I have a question regarding planetary atmospheres. I note that some planets rain diamonds and others rain sapphires. How do we know this? Spectral analysis tells us about atoms, molecules, and compounds. It cannot tell us anything about crystallography. You need to prove the lattice with X-rays for that. Is it possible that we're dealing with crystal forms of carbon and
Aluminium oxide,
right, respectively, that have not been documented? After all, we are discovering new crystal forms all the time. That comes from Nick in Perth. That's a really good question, yes. But we have heard of such planets that rain diamonds and who knows what else, salt-like planets and so on. And this is your area, isn't it?
Yeah, there's a lot of allegedly in this, I think. There's a lot of beauty and storytelling between what a paper says and what a press release says. I think that's maybe a polite way of putting it. So,
I know exactly where you're coming from. We refer to it as the popular press, clickbait, getting the headline, whatever you like.
Well, it's one of the reasons I've actually really enjoyed in the past writing for The Conversation, because as a scientist there I get to tell my story and the editor signs off on it and helps you write it, rather than it being passed through a lens of multiple stages where the story gets a little bit changed every time. which happens sometimes with press releases. Your university media office will often write a press release without consulting the scientists involved, because people are busy and they're doing them a favour. There's nothing sinister about it. And then journalists will base their stories on the press release, not the paper, but put their own spin on it, and so on and so forth.
Yeah.
Now, none of that is to say that there's anything dishonest going on here, but I think what happens is that certainly stories about planets around other stars that rain sapphires and diamonds are straying into the possible rather than the factual, if that makes sense. What we can learn about planets around other stars at the minute is, for the largest planets, we can start to learn something about their atmosphere, their composition of the atmosphere, the temperatures of the atmosphere, things like that. So one of the planets that has been flagged up as raining various precious stones is WASP 121b. And I've got an article open here in front of me where a sentence says, a place where winds blow at 11,000 miles per hour. It rains liquid metal, rubies, and sapphires. This description, worthy of a science fiction novel, actually corresponds to the reality of an exoplanet called WASP 121b. That's your story. When you actually look into what we've learned about WASP 121b, we don't know that there are rubies and diamonds in the atmosphere. What the study that birthed these stories told us was that the atmosphere is really, really hot, particularly on the sunward side of the planet. You're getting to temperatures of 2,500 to 3,000 degrees centigrade. That's 4,500 to 5,500 Fahrenheit, roughly. Ridiculously hot. We can see absorption bands in the atmosphere that tell you that there's water molecules, that there are titanium oxides, vanadium oxides, iron, chromium, vanadium, titanium oxide, vanadium oxide that have been detected in some studies and not in others. More recent studies have shown things like magnesium, calcium, nickel, all this kind of stuff. You then have studies of these kind of planets that can tell you the differences in the weather between the day side and the night side, and what's going on there. So I'm going to hop onto a different planet here because I've actually found a paper that talks about iron rain specifically.
Yeah, we heard about that one, I think.
This one sounds a bit more like the press releases about iron rain fit in well with what the science says, because what this paper found, which was published, the article is called Nightside Condensation of Iron in an Ultra-Hot Giant Exoplanet. This is another one of the really, really super hot planets, in this case another WASP planet, WASP 76b. What they've found is that they can get the spectrum with information about the daytime atmosphere on that planet and the nighttime atmosphere on that planet. The nighttime's colder than the daytime, but they find very strong winds blowing from the hot side to the cold side. You find incredible weather going on there. But what they've also done is resolved the signal of iron in the atmosphere there as iron vapor. But they've found that that signal is not visible on the night side, and it is visible on the day side. And it's visible in the day side all the way to the twilight side and then disappears. What they say, and again, I'll read this out so you can hear exactly where they're coming from. We're going to talk here about the blue shifting and the red shifting of the signal. That's relative to the zero speed. So if it's blue shifted, that's material coming towards you. If it's red shifted, it's material going away from you. And the speed is relative to the average speed of the planet. So the planet itself set at zero. That's just a context. And in the end of their abstract, they say, the absorption signal attributed to neutral iron is blue shifted by 11 kilometers per second on the trailing limb. This can be explained by a combination of planetary rotation and wind blowing from the hot day side. In contrast, no signal arises from the night side close to the morning terminator, showing that atomic iron is not absorbing starlight there. In other words, iron must condense during its journey across the night side. So you're seeing iron vapor in the evening when the wind is blowing from the hot side to the cold side, but you're not seeing iron vapor carried by the winds that go from the cold side to the warm side in the morning. So the iron has to have disappeared between sunset and sunrise, which means it must have condensed and fallen out of the atmosphere there. So that's where they're getting this idea of either iron rain or iron hail, essentially.
Yeah.
And that makes sense. You've got iron in the dayside atmosphere because it's super hot, but it precipitates out in the evening and it's gone by morning. So that's where the idea of iron rain comes from. with diamonds, we also have the discussion of diamond rain within the solar system on Saturn, Uranus, and Neptune. This, I think, was first postulated probably to explain the unusual amount of heat coming out from Neptune's interior, suggesting there have to be some physical process going on that is releasing latent heat and warming the planet up. And so the idea was that you've got this essentially carbon in the lower atmosphere getting under such high pressure that it solidifies and drops, and in that process you're releasing heat that warms the atmosphere. But there's a lot of discussion about the idea that very deep in Saturn, Uranus, and Neptune, you've got a domain where you have very high density gases like methane and ethane. And you also, a little bit deeper than that, the pressure is so high that any carbon would be squashed to become diamonds. There's a study that notes that Saturn gets lots of lightning, so suggesting that what possibly is going to happen is you have lightning strikes that break up methane and ethane, creating molecular carbon or atomic carbon, that then under the high pressure forms into molecular carbon and is squashed and forms little micro diamonds, and then they rain out and precipitate out and they're gone. That's the idea there. Now, we're not talking here about forming 100,000 carat diamonds. You're talking about little nano diamonds, little mini diamonds. But that's where that idea comes from. Now, this is all happening sufficiently deep in these planets that we can't see it. So it's all down to modeling based on our understanding and based on the observations of the outer atmosphere from Earth-based observatories and orbital observatories, from the Cassini spacecraft going around Saturn, and the data returned by Voyager. So it's one of those things where scientists are taking the information we know and trying to explain it and extrapolating to figure out what's going on in the interior of these planets. So to come back to the question, you are, I think, in many ways dead right. I think talking about raining sapphires and raining rubies and things like this is probably hyperbolic based on the information we have, but it's a way of illustrating just how extreme these planets are, just how totally unlike anything in the solar system the conditions are. And at least in the case of the raining iron thing, that seems to be well supported by the paper that talked about it.
Yeah.
The raining diamonds thing is quite widely discussed in solar system for Saturn, Uranus, and Neptune. And I think it's at that blurry edge where science and science fiction meet at the moment. So hopefully that's me being fair to the journalists involved and the scientists involved, but also trying not to muddy the waters any further.
Never let the truth get in the way of a good story.
Absolutely.
More or less. It's a great question, though. And, I think we clearly demonstrated we can't see this, but certain assumptions can be made. And then when you give that information to a journalist, they'll go, oh, I like that bit. There's the headline. Bam. I think Nick was on the money there. Thanks for the question, Nick. This is Space Nuts with Andrew Dunkley and Professor Jonty Horner. Let's take a short break from the show to tell you about our sponsor, NordVPN. Let's talk about your online security. Now, I can tell you from personal experience, last year when Judy and I were overseas, we ran into a bit of a frustrating issue. There were certain apps we simply couldn't use without a VPN connection, things like our banking apps. They wouldn't load, and even a sports app I rely on wouldn't let me watch games back home because of geofencing and things like that. So with NordVPN, I was able to watch football back home while crossing the Atlantic Ocean. It was pretty weird, but it worked. And NordVPN is the best in the business. With NordVPN, you can securely connect to servers all around the world, which means your apps think you're right back home, even when you're not. It also encrypts your internet traffic, hides your IP address, and keeps your personal data safe from hackers and trackers and anybody else who's trying to get at you online. And this can happen in public Wi-Fi situations, in hotels, airports, cafes, anywhere like that. The best part, it's fast. Thousands of servers globally, and their NordLynx technology allows you to run seamlessly. No slowing down. It is brilliant. Right now, you can grab the special Space Nuts deal through this URL, nordvpn.com/spacenuts. You'll get 4 extra months free plus a 30-day money-back guarantee. So there's absolutely no risk if you want to give it a go. That's nordvpn.com/spacenuts. spacenuts. Stay safe online with our sponsor, NordVPN.
3, 2, 1.
Space nuts.
Now, let's go to an audio question, which comes from Sandy in Melbourne.
My question this time is just around satellites, and in particular, the recent FCC approval of Reflect Orbital's test satellite, I believe. The Reflect Orbital proposal, as I guess hopefully everyone knows, it's a fairly one of concern, I suppose. I'm just curious about the approval process, and in particular why the FCC is able to approve something that can potentially impact the entire globe. I don't mean this question in any negative light. I'm just curious about the approval process and why there isn't maybe more international cooperation on approval of, these sorts of proposals that has the potential to impact the entire globe and not just the United States. Amazing. Thank you for an awesome show. Looking forward to hearing the answer.
Thank you, Sandy. Lovely to hear your voice. Hope all is well down in Melbourne, which is generally a colder place than where I am, but not by much. It depends on the time of year. But this is a controversial topic and one that probably won't disappear in the near future, with so many plans to put so many satellites in space, creating so much disturbance for astronomers. But Reflect Orbital, now that was a case of somebody wanting to create more light on Earth through reflecting sunlight. And it got deeply controversial because of certain approvals or applications that were made to the FAA. But before we get to Sandy's question, there is a story in the news at the moment about the FAA approving or trying to circumvent certain environmental laws for commercial launches and spacecraft reentries. What's that one about?
There's all sorts of kind of car crash news around this. And, thank you, Sandy, for the question. It's very topical. And it is all really reflecting the fact that the space industry is developing and evolving at a speed that is far greater than our ability to legislate about it worldwide. And in fact,
the internet did that too.
Oh, absolutely. The treaties that are in place that are very limited governing global use of space date back to the 1960s, when you were looking at a few launches per year from government agencies and nothing else. And they are wholly not set up for the current era of commercial space. You've then got the thing that people are trying to launch from more and more countries. Companies are designed to do what's right for the company, to try and make money. Now, people, will often say, well, why doesn't government X of country Y be stricter on the rules about launches and start cracking down on this? But the problem is, if you go to a company that's wanting to put things in space that will service one country or will service all around the globe, whatever, and say to them, you know what, we want to regulate about your launches, they can just say, well, thank you very much, we'll take our business elsewhere and launch from another country.
Yeah.
So there's a perverse incentive, I think, there for countries to not get in the way too much. What then happens is that there is some kind of level of regulation in that the country from which something is launched is normally responsible for if it falls back to Earth.
Mm-hmm.
The vast, overwhelming majority of launches come from the US and from US companies. And companies that want to launch in the US have to get permissions from US agencies. And it seems that there are two agencies involved with this. You've got the Federal Aviation Administration, who are the people who legislate around the launches themselves, where you can launch from, how many launches that there can be. And then you've got the FCC, which is the Federal Communications Body, effectively.
Yeah.
And what they are legislating for is the use of radio frequencies for communication. Right. So the recent permission for Reflect Orbital was actually FCC permission to give them the permission for the satellite to use certain frequency bands to communicate with the Earth.
Right.
So you are permitted to launch your satellite and use these things to communicate. The news story that you alluded to there is a proposal from the Federal Aviation Administration, who are the people that govern the launches in the US, that is following the recent policy announcements from the Trump administration more widely to try and get environmental regulations around launches repealed to allow them to fast-track launches, to remove blocks to the commercial activities and all the rest of it by getting rid of regulation around endangered species or native title or things like this. It's quite concerning when you read about it. The FAA proposal, this is me reading a quote, proposes to waive requirements of laws of the US for a license or permit after consultation with the head of the appropriate agency when the requirement is not necessary to protect the public health, safety of property and national security and foreign interests of the United States. Nothing in there about the interests or health and safety of people anywhere other than the United States. Of course, these launches pass over other inhabited countries as they're getting to altitude. There's nothing in there about environmental protections. They want to get rid of, and I quote, 13 federal laws to stop them applying to certain commercial space licenses and permits, with examples including the National Environmental Policy Act, the Endangered Species Act, the Clean Water Act, the Clean Air Act, and the National Historical Preservation Act.
Blimey.
So this is a little bit concerning.
Yeah.
People are getting a little bit worried about things like attempts to build launch environments in habitats for endangered species, all sorts of stuff like this. So that's going on. But the FAA are the people who approve the launches. The FCC, who are the ones that have just approved Reflect Orbital, approve the communications side of it. And they have been very, very clear in their thinking that they don't have any right to pass any opinion on the activities. They're just approving the communication channels. So again, quoting about the Arundel-1 satellite, Reflect Orbital satellite, loads of comments, loads of international concern. People raised it with the FCC to say, come on, really, mirrors in space, this is really dangerous, please don't approve this. And the FCC has said, we find that concerns about Arundel's impacts on optical astronomy fall outside our review and authorization of the space station and are not a basis for denial or additional conditions on the operations. And they went on further to say, we find that the operation of a solar reflector attached to a satellite is too attenuated from the Commission's action of approving use of spectrum and thus beyond our authority. So they're just passing the buck.
Yeah.
The thing is, though, you can see exactly the same buck pass being done by the FAA.
Yep.
When it comes to launch this thing, the FAA can say we have no ability to rule on what the satellite's going to do when it's up there. Our rule is solely to regulate on whether the launch can happen in a safe way. So it really does feed into this Wild West narrative that the commercial use has really outstripped regulation. It's arguable whether people are actually rushing to keep up or not, or whether there are less efforts being made to keep up than you would like. But certainly we're a long, long way from having any kind of oversight globally on the use of space or any way of managing it globally. There's a lot of discussions. I've got a PhD student studying with us at UniSQ remotely who talks a lot about satellites and the use of the night sky from the cultural lens and the impact on traditional owners of the land for whom the night sky is incredibly culturally significant, who don't have a voice. You know, we've spoken about that before as well with the idea of sending dead people to the moon, which is considered very sacrilegious to a number of native groups around the planet, but who cares? The company can do what they want, seems to be the impression. And the company involved were very caustic in their comments that effectively, we don't care, we're not going to listen, they should grow up. And it's fairly horrific in a lot of ways, this stuff going on. But it is fast developing industry with no regulation developed around it.
And that's because of the speed of technology enabling these things long before the legislation makers can do anything about it. And we see that a lot. I remember when email first started popping up, you could get away with practically murder on email because it wasn't a legal document. That law's been changed. But there was a time where it was such a grey area that email didn't count in terms of defamation or slander or any of those legal areas that could get you into trouble. That's now changed, obviously, and email can be used against you in a court of law, et cetera, et cetera. Now we've got this situation where the private enterprise is getting so involved in space and wanting to do all these extraordinary and somewhat, in some cases, ludicrous things, and the law hasn't caught up to it yet. And then you've got bodies that are saying, well, you look, we only deal with this little bit here. We got no say over the rest of it. So that's okay. We can let them do that. Someone else will have to decide what happens to the rest of it.
Even though those bodies are ignoring their own rules some of the times, there have been things permitted to use bands of the spectrum that have been meant to be kept safe and pristine for radio astronomy, and I'm sure Fred has had views on that in the past. Should say, incidentally, we've had a hello in the public chat from Moose Again, so hi Moose Again, or Moose Again. So I saw the chat thing flash up. It's like, what's going on? We have somebody listening, so hello.
Yeah, I can actually see the numbers. Yes, we do have quite a few people listening at the moment.
Fabulous.
So that's nice.
So I appreciate you keeping us company today. But yeah, it's a very bizarre situation, and it's hard to see how it'll change at the minute, especially given that the biggest players don't seem to be awfully interested in global rules and regulations. Maybe that's a way of putting it. And, you equally with the rate it's gone, you can imagine why they didn't legislate about this in the 1960s. Because can you imagine if the global bodies in 1967, 1969, when the Space Treaty was done, had put in rules about the commercial use of mega constellations? Nobody would have even thought about it. And anybody trying to be that forward-thinking would have been shut down. It's never going to happen.
Yeah, and yet it's happening as we speak. We're talking about two kettles of fish, but they kind of interrelate in regard to what's going on in low Earth orbit, and what the future will hold, I do not know. But when you've got federal government organisations that are kind of wanting to manoeuvre around certain legislation and certain acts of parliament, depending on which country you're in, that's a bit of a worry.
Yes.
Thanks for the question, Sandy. It's a pretty deep and meaningful one, and very controversial, and certainly not going to go away in the near future. But hopefully common sense will prevail. Good question. This is Space Nuts, a Q&A edition with Andrew Dunkley and Jonty Horner.
Okay, Houston, we've had a problem here. This is Houston. Say again, please. Houston, we've had a problem. We've had a main beam undervolt. Roger, main beam undervolt. Okay, stand by 13. We're looking at it.
Space Nuts.
Our final question is a very quick and easy one, except I can't find it. Here it is. This comes from Rennie, who's a regular contributor at sunny West Hills in California. Can planets form without a sun? Let's say because dark matter would be the gravity, Rennie is asking. Well, planets are your thing. Can planets form without a sun? Now, we know there are rogue planets, but we're going to assume that they were once part of a system that probably had a star at its centre and it got booted out for not paying the rent or something. But that's not what we're talking about. We're talking about planets forming without a star or a sun, whatever you want to call it.
Yeah, and there's all sorts of different angles to this. Now, dark matter is not really well understood. I'm not a cosmologist, but there's a number of different things that have been proposed to be dark matter. And I mean, fundamentally, at the simplest level, anything that has mass that cannot be seen can be considered dark matter. So I guess to some degree you could consider black holes dark matter when they're not feeding on something. We can see the evidence that the mass is there, but we can't see the material itself. There was a story a few weeks ago, and I'm remembering this off the top of my head, don't have it up in front of me, where people had done research looking at the incredible accumulations of material you can get in the interior of very massive galaxies, material that's been corralled by supermassive black holes, suggesting that you can get at certain distances from supermassive black holes enough density of material that you could get spontaneous planet formation happening, forming trillions, quadrillions of planet-sized objects in the kind of inner reaches of a galaxy, not forming stars, forming loads of planets. So that's one way this could happen. You also have ideas of things like planetary formation around objects like white dwarfs and normal-sized black holes and neutron stars. We found planets around pulsars in the past, and planets around pulsars pose a real problem because you'd expect that a pulsar being the result of a supernova explosion, the supernova would have destroyed any planets that were in orbit around the star, or they'd have escaped, bit of both. So how can you have planets around a pulsar? And one of the suggestions is you get a second generation of planet formation where some of the material from the death of the star falls back to form a disk around the star, the stellar corpse, and you get a generation of planet formation that forms objects like the size of the moon and a bit bigger, a bit smaller. So you can get that. You also have the possibility of forming objects the size and mass of planets in star-forming regions as almost like mega-failed stars. And this goes back to something we discussed on the previous episode about when is a star not a star. You get objects that are not massive enough to be a star get called brown dwarfs. That's why you've got something more than 13 times the mass of Jupiter, less than 80 times the mass of Jupiter. And we know you can form brown dwarfs in star-forming regions where you form something that just doesn't get massive enough to begin fusion. If you're forming things that size, you will also form things that are smaller than that. And so you will form free-floating things of planetary mass in star-forming regions. So in that way, you could get planets forming without suns in that way. In terms of dark matter being the origin of the gravity, this is where you could get a really awesome collaborative project going between cosmologists and exoplanet people, where neither of us has all of the knowledge to absolutely definitively answer that. So I'm going to give the caveat that what I say from now on is based more on judgment than knowledge in a way. My memory is that most discussions of dark matter these days seem to talk about it being very distributed, very finely spread. So it's not like you get isolated clumps. You don't get a planet-sized clump of dark matter planet. You have a lot of material spread very wide. And that means you wouldn't have like a nucleation site around which material could gather to form a planet. In that paradigm of the dark matter all being very thinly smeared out and very spread out. If you had, though, in a star-forming region, a clump of dark matter that was the mass of the sun, that could form a disk around it where planets could form. So if you could get that clump of matter the size of the sun, the mass of the sun, then things would happen around it just the same as if it was any kind of visible matter, baryonic matter. Because all that you're looking at there is gravity doing what gravity does. The thing is, my understanding here could very well be flawed, is that most cosmologists these days talk about the dark matter being very spread out, which would kind of preclude that kind of setup happening. If, however, you go back to the days where people talked about the potential origin of dark matter being what were known as machos, massive compact halo objects, that version of dark matter was the idea that you had massive objects that you could not see, whether that's brown dwarfs, whether it's black holes, whether it's things like that. Things that are large, localized agglomerations of matter that are not visible for whatever reason. Those kind of things could be seeds. They exert gravity. You can imagine if one of those was in a star-forming region, it could get a disk of material around it. Now, it would also accrete itself baryonic matter, which means you could potentially get stars that are formed with a core of dark matter in that type scenario. But we are getting beyond my area of expertise there. So we are kind of verging on the speculative and the science fiction rather than the science facts. I do want to caution that take what I've just said with a pinch of salt.
No, fair enough. But the bottom line is the answer to Rennie's question is probably yes.
Yes, for a given version of what dark matter is. You know, like I say, we have found the pulsar planets. There are, like I say, you can look up the paper from a few weeks ago, the news articles from a few weeks ago that were talking about planetary formation near supermassive black holes. You know, you could very much argue that supermassive black holes, when they don't have active material falling into them, are invisible but for their gravity, so therefore are dark matter by definition because they're matter that is dark. So yeah, there are ways to answer the question in the affirmative, but I think if you went down to the kind of very thinly smeared dark matter, then that side of things probably not.
Okay. Now, fair point. And as you say, we don't know a lot about dark matter, and we're at the very dawn of that, trying to figure it out. Someone will crack it sooner or later, but at this stage, it's all a bit of a head scratcher. And let's not get into dark energy, because that's, that if dark matter's a head scratcher, dark energy is boring out your brain with a pneumatic drill type of scenario.
Oh, it is. I mean, we're very fortunate that we do have here in Australia some of the world's foremost experts in these kind of things. It's just I'm not one of them. And I would encourage, having a special at some point with the incredible Professor Tamara Davis from the University of Queensland, because she can speak about dark energy and dark matter in a way that makes you think you understand them. There is no greater praise of a science communicator than that.
That would be fascinating. Yeah, that's a great idea. Rennie, thanks for your question. In regards to your grandchildren, Rennie messaged us not so long ago to say that one of his grandchildren, through Space Nuts, has now been inspired to include astronomy into part of his college studies. So we were really thrilled to hear that. So awesome. Thanks for the question, Rennie. And I think that's just about it. Yes, I think we'll call it quits here, but we will remind you that you can send in your questions via our website, spacenutspodcast.com, spacenuts.io. Either of those platforms work. And click on the Ask Me Anything button at the top. It's labelled AMA, and you can send us text and audio questions there. Don't forget to tell us who you are and where you're from. And have a look around on our website while you're there. And I'll remind you too, wherever you listen to us or watch us, please leave reviews. Apparently they help. I don't know how they help. I don't think they feed the hungry, but they might. I don't know. And Jonty, thanks so much. We will look forward to the pleasure of your company again in the next episode.
Yeah, looking forward to it. Thank you for having me.
Professor Jonty Horner, Professor of Astrophysics at the University of Southern Queensland. And thanks to Hugh in the studio. Hugh couldn't be with us today, surprisingly. Apparently he applied to the FCC to get approval to log into the show today, and they said no. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.